Hello, geometry students. In this lesson, an introduction to trigonometry, probably one of the most important concepts there is. It's one of the most important areas of math. It literally means the measurement, metry, of trigons, which means a triangle, three-angled figure. So, for example, if you have a triangle, it must be a right angle. You're going to always have a hypotenuse. And all I'm going to do is I'm going to say for this angle here, I'm just going to say this side is the opposite, this side is adjacent, this may be 4 feet, that may be 3 feet, and that may be 5 feet. I'm just going to do fractions. I'm going to take 3 divided by 5, or 4 divided by 5, or 3 divided by 4. That's all there is to it. It's just that we do this so often we decide to call it something. We call it the sine. The sine of an angle is equal to the measurement of the side that is opposite from that angle over the hypotenuse. The cosine of an angle is the measurement of the side that's adjacent over the length of the hypotenuse. And the tangent is the measurement of the side that's opposite over the measurement of the side that's adjacent. Well, what does that mean? First of all, you should always identify your hypotenuse. That never changes. The hypotenuse is always across from the right angle. We will never be standing at the right angle, but I am standing here at theta. If you're standing here at theta, this side is the opposite side because it's over on the other side of the triangle. And this side is adjacent because it's attached. It's the distance between the distance of that side which is attached to the angle where you are standing. Once you have gotten your sides identified, then you can go ahead and calculate it. One way of remembering it, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is the length of the opposite side divided by the length of the adjacent side. I can't remember SOHCAHTOA because I don't know how to spell it. I remember Oscar had a heap of apples. That's sine, cosine, tangent. That's established 3,000 years ago. Most important thing is to make sure you have identified your sides correctly. I have a right triangle. Always across from the right triangle is your hypotenuse. If you have a right triangle, it doesn't matter how it's positioned. Always across from the right angle is the hypotenuse. It doesn't matter how it's positioned. It's always across from the right angle. A lot of people will put the hypotenuse on top. It's not. It depends on how the position of the triangle is. Well, I'm standing here at A. If you stand here at A, which side is opposite? Well, this is the opposite side, making this the side that is attached, adjacent, next to. So if I try to find the sine of A, I'm going to find the measure of the opposite divided by the measure of the hypotenuse. How about this one? I'm standing here at this angle. That means this side right here is attached. It's the adjacent side. And then the side that's over on the other side becomes my opposite side. Keep in mind that if you switch positions and move to the other corner, then the definitions of opposite and adjacent will reverse. It depends on where you're standing. Well, I'm going to show you on this problem. I want to identify the sine of both of these angles. Well, before I get started, I'm going to say, here's my right angle. There's my hypotenuse. Then I need to go back and label which is opposite, which is adjacent. But I can't do that because I don't know where I'm standing. 8 is going to be the opposite for one angle, but it's going to be the adjacent for another. So I'll get to that. The definition of the sine of an angle is equal to the opposite over the hypotenuse. Well, I'm going to call this alpha and this one beta. So for alpha, the sine of that angle, which I don't know what it is, I don't know, it looks like 37 degrees. The sine of this angle is equal to the opposite side is 8 divided by the hypotenuse, which is 17. That is the sine of that angle. Whatever measured degree is, I don't know. Now we're going to get the 4-digit decimal for that, but I actually prefer the fraction because it says opposite over hypotenuse. What if I switch positions and go to the other side? There's alpha. But if I move down here to beta, the number changes. It's still the same definition. The sine of this angle, which I don't know, maybe it's 53 degrees, is going to be opposite over hypotenuse. But opposite has changed. It's no longer 8 because that's attached. It's 15, which is on the other side. The hypotenuse hasn't changed. The hypotenuse is always across from the right angle. So the sine of that other angle is that. That's the definition. That's just a ratio of two sides. It's 8 feet divided by 17 feet, or it's 15 feet divided by 17 feet. Well, how about the cosine? It's the same thing. We just call it something different. And this time we're going to use the adjacent side. Well, identify your hypotenuse. Identify the adjacent and opposite, but I can't do that because I don't know which one is which. I have to label the angle first. If you're standing here at alpha, this is adjacent. If you're standing at beta, the 8 is adjacent. So for alpha, the cosine of that angle, I don't know what it is, it's probably like 37. The adjacent side is 15 over 17. That may look familiar. That number is still in my calculator from the last problem. That's because the cosine of alpha is the same thing as the sine of the other angle. We'll talk about that later. How about the cosine of the other angle? Well, if you're standing up here at beta, 15 is not the opposite. It's 8 that's attached. The hypotenuse never changes. And there's our 4-digit number for it. That's the cosine. The last one, how about the tangent? The tangent of any angle is the measure of the opposite divided by the adjacent. I still have to identify the hypotenuse, but I'm not going to use it for tangent, so mark it out. This is my alpha. The tangent of alpha is equal to the side that's opposite, which is the 8, over the side that's attached or adjacent, which is 15. What if you move to the other side? The other corner? If you're standing at this angle here, these switch position because it's the 8 that's attached and the 15 which is opposite. So the formula for tangent is the opposite over the adjacent. It's not a coincidence that these two are reciprocals of each other. That will always be the case. It's just that it depends on where you're standing. So that's sine, cosine, and tangent. Do the same thing for one angle here. I want to identify the sine, cosine, and tangent for this angle. I don't know what the measure of this angle is. It could be, I don't know, it looks like it's about 30 degrees. It doesn't matter. I can find that later. But what matters right now is identifying these sides. This is the hypotenuse. It's always across from the right angle. Attached is your adjacent. And then over on the other side is your opposite. Now that you know them, plug them in. The sine of that angle, I don't know what it is, like 30 degrees maybe. If you're standing here, the opposite is 10. The hypotenuse never changes. I'm going to figure out what that is, even though I like the fraction better. This happens to be 55/47. How about the cosine of theta? The cosine of this angle is just the measurement of the side that's adjacent divided by the measurement of the hypotenuse. Well, the length of the side that's adjacent is 15 feet. The length of the hypotenuse is weird. It's about 18 feet, but I'm going to put it in as 5 times the square root of 13. Whoops. Trying to find out what that is. And it's about 83. 1. I really don't care what those numbers are. I care what the definition is. What is the tangent of this angle? It's the measurement of the side that's opposite over the measurement of the side that's adjacent. That is the tangent of that angle. I don't know what that angle is, but I know what the tangent is. All right, look at this last page. Given the angle measure, you always have to have the sine of an angle, tangent of an angle, cosine of an angle, the cosine of an angle, the sine of an angle. It has to have an angle. You can't just say sine. It doesn't make any sense. You have to have an angle. Normally this would be a ratio, opposite over hypotenuse. But since I don't have a picture, I'm just going to go straight to my calculator. It's already been determined for me. This is not a calculation. This is like going to the back of the book. Somebody already measured for the sine of 47 and found out that it is equal to 7314. That's just straight off my calculator. Go to your calculator and type in tangent of 89. It's equal to 57.289. Actually, it rounds up. Go to your calculator and type in, what's the cosine of a 17-degree angle? Well, the cosine of a 17-degree angle is equal to the measurement of, equal to the measurement of that side divided by the hypotenuse. Somebody's already done that for me, and they found out that that ratio simplifies down to this 4-digit number. What's the cosine of a 52-degree angle? It's already been done. The cosine of a 52-degree angle is already stored in your calculator. Whoops, I was putting in as a fraction. I've already done the fraction. It's 61/57. How about the sine of 23? 3907. And finally, the tangent of 50. That's 1.1918. And that's that. That's an important topic.